A piecewise function is a function that has more than one rule associated with it. Each rule is associated with only a piece of the domain. So in the g of x function here is x squared if x is between 0 and 2, including 0 but not including 2, and it is 2x minus 4 for x greater than 2. So if I'm going to evaluate the function, I have to first look and see which section of the rule, which rule that I use for each input value. So g of 0 falls in this section of the domain, so I use the first rule. So g of 0, I'm referring to this rule, so that's just 0 squared, which is 0. Now for g of 2, I look and see, is 2 in this section of the domain? No, because x is less than 2. Is 2 in this section of the domain? No, because x is greater than 2. So g of 2 is undefined. 2 is not in the domain. Okay, kind of tricky. You have to watch out for that one. Okay, g of 6. 6 is clearly greater than 2, so for this one I am in this section of the domain. So I will say g of 6 is 2 times 6 plus 4, or minus 4, so that's 12 minus 4, which is 8. Okay, so that's how you evaluate a function. So you might want to stop and try this one and try putting -1, 4, and 7. For those of you watching in 2018, change the third function to this function. Everybody else should have the updated one. Okay, so pause your video, try it yourself, and then turn back on. Okay, if you've turned it back on, then let's check and see if you got this right. So -1 is in between -3 and 4, so we're going to use this section of the domain. I do the absolute value of -1, which is 1. 4 is in this middle section because it just says h equals 4. So I say 4 minus 1, which is 3. The third one is 7, which is not in any of these three domains because the largest numbers are the third section and it only goes up to 6. So this is not defined or undefined. 7 is not in the domain. So the domain of the function is listed over here, and each section of the domain is associated with a different rule. So what does the graph of one of these things look like? Well, in number 1, I've gone ahead and drawn in kind of in a gray line here what the graphs look like. But this is not how you graph it, because this is clearly not a function. If I put in 1 for x, that would give me 2 different y's, so that it would not meet the definition of a function. So what I have to do is I have to graph each section of the rule, but only use part of each graph. So here's my graph of x squared, right here. So this graph is x squared. For x squared, I only am going to use values of x that are equal to 0 all the way up to but less than 2. So I want to remind you that when I have a less than or equal to sign, then that includes the point, but less than 2 does not include the point. So my section of the graph is going to look something like this. So I am going to put a circle where x is 0 on the graph of x squared. Then I'm going to go over to where x is 2. X is 2 over here, and I'm going to go up to the x squared graph where x is 2, and I'm going to put a open circle there. Put an open circle there, and then I'm going to use only the section of the graph that is in between the x values 0 and 2. So we can think of this as kind of a section of the graph here. So I'm only looking at the section of the parabola that is in between 0 and 2 on the x-axis. Now I'm only then for the other graph, which is this line 2x minus 4. Okay, so this is a line that if I put 0 in for x, I would get -4, so that's the y-intercept. and it has a slope of 2, so if I go over 1, up 2, over 1, up 2, it has that slope. I could graph that line by making a t-chart, putting in some values for x, finding y, plotting some points. But anyway, this is the line. I'll put this in black, I guess. This is the line of 2x minus 4. Okay, so y equals x squared, y equals 2x minus 4. So when I only want the values where x is greater than 2, so that would be 2 or greater. So where x is 2, I put a circle, an open circle on the line, and then I look for values on the line where x is greater than 2, so that would be the other section. So I want all the way from where x is 2 to infinity, but these are actually the values of x on the line. So my whole graph looks like this blue piece plus this black piece. Now if we look at the domain here of the graph, the domain is these two domains put together. So since there is no value at 2, my domain looks like this. 0, which is in square brackets because it is included, comma 2, or 2, comma infinity. Now if one of those values had been an equal to 2, if either one of those they both couldn't be equal to 2 or it wouldn't be a function, but if one of those, then my domain would have gone all the way from 0 to infinity with no break, but there's a break there. The range is everything from the lowest value of y, which is 0, to the highest value of y, which would be infinity because it goes all the way up. So notice I have any value for y is covered. Now some of them are on both sections of the graph, but that's fine because one y can have two x's, just one x can't have two y's. So my lowest value is 0, my highest value is infinity for my range. Now discontinuities, what's a discontinuity? A discontinuity is where I would have to jump from one place to the other when tracing the graph. So tracing the graph from starting with from the left to right, I'm going up this section. Now I have to jump down here and then trace. So there is a discontinuity, and the discontinuity occurs when x equals 2. So discontinuity is it's a break in the graph. I have to pick up my pencil to trace it. Okay, so there's a break in the graph. We look at the break in the x direction. There's a discontinuity at x equals 2. Okay, so let's look at this one. It's not drawn at all, so we need to figure out how to draw this. So we have 3 sections of the graph, and I'm going to go ahead and number these. 1, and I'm going to put them in different colors to make this easier. 2 and 3. Okay, and I don't know how much room I'll have just over to the right here, so I'm going to put section 1 up here. So number 1, let's get back to my correct color. So 1, the first section of the graph is that h of x is equal to the absolute value of x. Okay, so what does the absolute value graph look like? No matter what x is, y is going to be positive. So if I look at my x and y values, so for example, if I have -1, I get 1. If I put in 0, I get 0. If I put +1, I get 1. So here are 3 points on the graph: -1, 1, 0, 0, and +1, 1. Now, I could also do 2, 2, and -2, +2, and so forth. So the graph looks like this. It's a V-shaped graph that goes over 1, up 1 in both directions, okay? With a positive slope for over here and a negative slope over here. Now, I'm only going to use the section of the graph from -3 to 4. So let's find where -3 is. So -3 is right here, and +4, 1, 2, 3, 4 is right here. So from this section, from here to here, is the only section of the absolute value graph that I'm going to use. And notice -3 and -4 are not included. So that means I'm going to have an open circle both ends here. So I'm going to have an open circle here, an open circle here, and then I'm going to use the middle section, everything in between -3 and 4 for the absolute value graph. Okay. Number two, it's the equation is h of x equals x minus 1, but only for x equals 4. So if I'm just going to go ahead and plot that one point. When x is 4, y is 4 minus 1, which is 3. So it's just going to be 1 point, the point 4, 3. So 4, 3 is right, oops, not there. Delete that. 4, 3 is right here. So for graph number 2, that's all we have is just that 1 point. Okay, graph number 3. Graph number 3 is h of x equals 1/2 x minus 4. So graph number 3, h of x equals 1/2 x minus 4. Now that's only from values from 4 through 6. So let's go ahead in our t-chart and let's just use those values. 4, 5, 6. Okay. So 1/2 times 4 is 2. 2 minus 4 is -2. 1/2 times 5 is 2.5. 2.5 minus 4 is -1.5. 1/2 times 6 is 3. 3 minus 4 is -1. I probably don't really need that middle point. The other two would be sufficient. So I have 4, -2. 5, and I have 6, -1, and I have 5, -1.5. So basically I'm looking at this line right here. Okay, so there's the line I'm looking at. But I only want the section of the line from 4 to 6. Open at 4, open at 6. So open circle at 4, and so I might actually erase this so that's clear that that is an open circle. So open circle at 4, and I might have to erase over here a little bit too, and an open circle at 6, and everything in between. Okay, so what does my whole graph look like? My whole graph looks like this black section with 2 open circles, this red section with 2 open circles, and this one blue point. Now these dotted lines I put in here kind of help me to figure out where the graph is. You can erase them afterwards if you want to, or you can leave them in there to just, as long as they're light and they're dotted and you can't really, but the darkened in part is my actual function. So once again, let's look at domain and range of this function. So the farthest left my graph goes is -3, and the farthest right my graph goes is 6. So I don't have any values to the left of -3 that are on the graph, because remember that wasn't included, and anything to the right of 6. You can also see that from up here. -3 is the lowest and 6 is the highest. They are both open endpoints not included. Now, are there any gaps? Well, it goes from -3 all the way up to 4, but not including 4. But there is a value when x is 4, and then we jump down here, and then we go up to 6. So there's a continuous, it's continuously value, that we have all the values of x all the way from -3 to 6 are included on the graph somewhere. So we can say -3, 6. Okay, so there's the domain. Now the range is the lowest value we have here for the range is when y is -2 here, but it's not included. It's up to -2. The highest value up here is when y is 1, 2, 3, 4. Okay, that's the highest. So we go from -2 to 4. Now, do we include everything? So let's look here. We go from -2 to -1 right here in this section. So this section goes from -2 to -1, but then there's a little gap. There's no place on the graph between -1 and 0. So we have this little section on the graph is covered, and then everything from here to here is covered for y, but not this little, there's a gap right here. Okay, so we have to, and remember these endpoints are not included here, so it's going to be -2 to -1, endpoints not included, or now 0 is included, 0, comma, -4, -4, not included. So it's a little more complicated. Now, what about a discontinuity? This does not count as the discontinuity. The discontinuity is a break in the graph as we go from left to right. And maybe I should write that. Okay. Going from left to right. So in other words, the discontinuity is, we talk about the discontinuity in the x direction. So if I trace my pencil here, okay, no discontinuity so far, I haven't had to pick it up. But right here, I have to pick up my pencil, jump to this dot, and then just jump down to there, and then it goes on. So at x equals 4, there are actually 2 discontinuities, okay? But I'm not going to worry about the fact that I have to do it twice, but there's discontinuity at x equals 4. Okay. This video is already 15 minutes long, 16 minutes long, so I'm going to stop and do the second part in another video.